We'll resume the talk. Can you give me the remote, please?
No, it's not working.
It's not working. Okay, great.
So I think we are.
So Sinon.JS. Yep, here we are. So we'll speak about Sinon.JS. What is Sinon.JS? It's a standalone test library for JavaScript, which is supposed to work with any other libraries. It can work with QUNit, it can work with Jasmine, or any other, for the instance. It was created by Christian Jordan, which is also the creator of Juicer, and one of the core developers of Buster.js, which we'll speak also in this presentation. It's also the author of Test-Driven JavaScript Development, which is a very good book about testing in JavaScript in general. The initial release was in June 2010, and it's currently in active development, even if it's very stable. It works on any environment. It can be launched in browser launcher like QUNit, in Node with Node Unit or Mocha chai, for example, or any other test libraries. It has a lot of interesting features. It can be used to spy or Stubs function or mock a whole object. I will come back on this later. It can simulate fake timers, fake AJAX requests, fake server, which is just a fake AJAX request advanced. It can be used for sandboxing in an application or in test, and it has its own assertion on matchers like chai. So, what is a spy? A spy allows spying of function. It can be used to tell if a function has been called, how many times it had been called, what the parameters which has been used, what was the call context, this keyword, if an exception was thrown or not, and the order of the call. There is a complete spy API with example on the right. The API is very complete. For example, in Jasmine, there is also spies that you can check if the spy was called or not called. In Sinon, you can check if the spy was called, if it was called once, called twice, called thrice. You can filter the calls. For example, you can ask if the spy with arguments hello, for example, was called or was called once, it cascades the API. It's very complete also with the arguments. You can access specific information for a specific call to say when it was called, which arguments, which context, and you can also check if it was called before or after another call, or another call group, per instance. Stubs. Stubs inherits from the spy API, and it adds stubbing method. Stubbing method, it's more or less what we will call mocking in Java or in any other language. It allows to replace an existing function with a stub function, which can be used to tell what will be returned. For example, you stub a function, the example on the right says by default when called it will return stubs. You can also, like the spy API, filter. For example, the stub when called with arguments hello as first parameter will return the first argument. Or you can ask the stubs to throw an exception with the specific arguments. Mocks. Mocks are just when you stubs a whole object. Mocking an object converts every method of the object as expectations, which are stubs, and call validation methods, which will allow the test frameworks to check if the stub was correctly called. For example, on the right, you define a greeter object with a greet function. You ask Sinon to mock the greeter, and you define an expectation. Your test is supposed to call greet with argument John only once. If, when you call mock.verify, if all the expectation has been met, it will do nothing, else it will raise an exception, which will use by any test framework to check that the test is failed. Fake timers. I don't know if you already tried to write tests in JavaScript with timers or AJAX requests. Anything that's asynchronous, but it can be very difficult because asynchronous means callbacks. Many asynchronous calls means many callbacks, and as we've seen in the Zombie demo or any asynchronous demo, it makes a pyramid of calls which is just not really readable. The fake timers allow to handle set timeout and set interval like as synchronous methods. That means when you call a set timeout or a set interval, you will have access to the clock object, which is from Sinon, which can be used to advance the time. For example, we will here set a timeout method on the SPI of 150 milliseconds. We use the clock to tick 149 milliseconds. The SPI is not called. If we tick one more millisecond, we can see that the SPI has been called. All this is synchronous call. There is no callback. There is no waiting. This is used for readability. This is very easier to test timers on the timeouts code. Fake AJAX requests are the same, but with AJAX requests, which are asynchronous by nature. You can ask Sinon to emulate XML HTTP request with synchronous, and then you can make AJAX call, ask Sinon to answer to this request, and handle it in a synchronous way. Like we can see there, you ask Sinon to use fake XML, and you define that on the new XHR object, when a new AJAX request is created, you push it on a request queue. Then we ask with jQuery to query a remote resource, and we can synchronously respond to the request. The fake server is simply an advanced API for the fake AJAX. You can use it to filter which URL will respond with what data, because it can be complicated. If you have a complex test, we will get data 1, data 2, data 3 and work with it. It can be very verbose to use fake XHR. So the fake server have a high-level API with, for example, respond with, which will define for which method, which URL path, what's the response, which will be a response code, content types or any headers, and the response body. Sandboxing. Sinon allow isolation with sandbox to allow to protect the application from the faking features. For example, when you choose to use fake timers or fake server, you have to restore the original features after the test, because else all your application or all your other tests will be mocked, and this is not the behavior expected. So you can manually declare a sandbox and use it, but in the test frameworks which use Sinon, use it internally to restore after. For example, in QUNit, you use the sandbox in the setup method, and you choose to restore the original features in the teardown. I say that Sinon works with any test frameworks. So here is a non-exhaustive list. It can work with Jasmine, Chai, QUnit, Node.unit. The features depend. For example, in QUnit, you can use the matchers, you can use pretty much everything. In fact, you can use fake timers, you can use spies. In Jasmine, you can choose to use spies or not, because Jasmine has its own spy and own spy assertion. So you can choose if you want to use the Sinon spies and assertions in Jasmine, or if you just want to use, for example, the fake timers or anything. So in a few words, it's a very powerful tool. The great power of Sinon is the spies, the stubs, and all this smoking stuff, which is or not available in other frameworks. The advantage is that you can use in any other. For example, if you started your project with QUnit, which is really too simple, with no spies, which has no mocking, no Ajax mocking features, you can then later add Sinon to add all this stuff. In other level, I think the spy API of Sinon is simply the best of any frameworks. The Jasmine one is not that great. Even in Karma or anything else, I think the Sinon API is very the more complex. What to say? Beware of date faking. I spoke about the mocking of set timeout, set interval. With Sinon, you can also mock date, the date object if you want, which will be able to advance the date time with the clock, like you could do with the set timeout. But any date libraries that you could use, for example, mouvement.js or date.js, keep a reference of this date object before Sinon took it. So if you use moment in your test or in code your test use, you could have very bad behavior. And in EA, Internet Explorer, 6 and 7, some of the fakings doesn't work really great. It's supposed there is a bridge, there is a Sinon-Internet Explorer.js, supposed to make all the features work, but we had really bad behavior with Ajax faking on EA6.
No, it's not that big deal. The talk is about modern web application.
Yeah, that's it. But even today, some clients require us to.
You want to make a demo, right?
Sorry?
You make a demo about it?
Yes, I will make a quick demo about spies behavior. So I have an empty QUnit. So for example, I will use QUnit as a container. So I will simply test Sinon spies. This will not test real code, this will just show the behavior of spies. So I can define a spy like this. And I can use the spy. For example, I can check that the spy wasn't called. So I can say this. I can check that the spy I just created is not there, is not called. Then I will call it. I simply can check that the spy was called and that it was called once. This API calls, called once, called twice, etc., are very useful because a few times you have to synchronize some stuff, and it's very practical to be able to check how many times, verbosely, how many times the spy has been called. You can also do something like this. I think it's calls .length equals 2, but in call twice is just very more explicit. That's about how the spies work. I will show you also how Stubs works. Testing Sinon Stubs. The declaration is the same. So I just created a stub with no behavior. So if I call it, it should be undefined, I think. Yep, it is. So I can say stub returns. I can ask my stub to return OK. Then I will check that the call to stub returns OK. Then I will ask him that with argument, say dolly, it will returns KO. And I can do a second test. To check that. Here we go. So the withArg method is very useful. And it can also be used to check the call. I mean, like in the spy, I could also do this. Stub with args the dolly .killed once. This allows easy filtering when checking for a call. Expected undefined returns true. Yep. It was OK, not equal. Here, last example, I will show you the faking of AJAX request. Test fake XHR. Fake server, it will be easier. So I define the Sinon server, fake server.create. I do not forget to restore it at the end. It will be in the setup method, but in the teardown, but I will just do it there for now. Server.restore. It will tell Sinon to restore the original. Then I will do an AJAX request, getting, say, data.json, response, and I will check that the response.length equals 1. I will just do a quick copy because it will be too long to write. Here's the interesting part. I say to the server to respond to any call with a 200 response, which contains a simple JSON array of length 1. I do my AJAX call. If the server was not mocked, I will be forced to do an async test like that, and saying and asking QUNit to start there. We start. With Sinon, I can do a normal test and simply telling the server to respond there. Here we go, synchronous Ajax call. That's all.
Yep, that's good.
Yep.
All right, hold on. Before changing, I think one thing which is very useful with the fake server is it allows you to check all your client-side stuff without having actually to start up the server itself. So as starting the server, stopping it, etc., takes some time, I think you can handle a little bit by that, with that. And the other point is that I don't know if you're serious about Java programming, but you probably knows a little bit of your testing tools in Java. You probably use JMock, EasyMock, and end up using Mockito like everyone else. And actually, if you know those tools, you have seen that Sinon is giving you quite a few of the same kind of stuff that you are used to when you're playing with Mockito and all the stuff. So it's very, very comfortable for a Java programmer to start up with Sinon, since it gives you the same kind of stuff you're used to. Let's talk about Karma a little bit. You want to say something else?
No, that's
okay.
Okay,
go. So Karma. Actually, we gave this talk at DEVOXX France last year, and at the start, the Karma was not called Karma; it was called Testacular. And actually, they changed the name the week before the talk. So we had the whole demo stuff, which has to be changed, and I don't know why they changed, but anyway, that's the way it is. So now it's called Karma, anyway. I think the developer Karma is somewhere. He gave a talk this morning, so if you want to have more stuff on Karma, I think you can ask him directly. Anyway, what Karma is? It's a test runner. Okay, it allows you to run tests. Okay, that's almost all. It runs on Node, so actually you can just npm install it. It allows you to run unit testing and end-to-end testing in some kind. And it does this with many browsers at the same time. So actually you can write some unit tests and run them at the same time in Chrome, Safari, Firefox, and whatever, Opera, etc. It's developed by a member of the AngularJS team. And I don't think it's directly developed by Angular team. It's version 0.1. And basically how it works, it's quite clever. That's the schema here. Sorry, we know the screen is a little bit blurry, but well, that's all we have. So actually you just Karma start, and then it start up a web server which is going to show you in a web page, the tests running, like QUNit. And then you will have an iframe within it, with your actual application running inside this iframe. So whenever you are going to see the test, like in QUNit, test 1, test 2, test 3, test 4. And then, at the same time, you can see the page actually moving in front of you. Hi, I'm going to do a demo just after that. That's the way it's run. So as you see, it's a web server calling another web server, including itself a web page calling the other server. So it's quite some stuff. And you will see that the configuration is not that easy. So Karma is able to handle those browsers, actually, and at the same time. That's what I really like. It means that if your test suite is able to be parallelized, meaning that you can run many tests at the same time, you can run them in parallel with this tool. The fact is, if you're using a database, and if you're doing stuff like initializing it, running some tests, re-initializing, run some more tests, you're going to be in trouble to parallelize them. So it depends on the situation, but at least the tool is able to do it. For unit testing, it's perfect, but if you're doing acceptance testing with it, you can run into some kind of limitation with it. But it's not Karma in itself, right? It's the way your tests are written. It supports many testing tools. Actually, it's a runner. So it's going to run something in a browser, and the something can be this. I think there is many more now. For unit testing, we usually use Mocha or Jasmine. And there is the one, which is at the end here, which name is Angular Scenario. And actually, if you take a look at the Angular web source, you're going to see that they're using Jasmine for all the unit testing, and they're using Angular Scenario for the acceptance testing. So if I can make a parallel between those two kind of suits and what we've done before, what you've seen before in this presentation, Mocha could be things like Sinon and QUNit, and the Angular Scenario is more in the same category as what we've shown you at the start of the presentation, like Phantom.js, Casper, and Zombie. So what it looks like, I say funky configuration file because it's very, very heavy, right? I've shown you how to start hand-to-end tests with Zombie, and it was like 3 lines of code, right, with no configuration, nothing. You just run, bam, out of the way. You have to write this kind of stuff if you're going to use Karma. They actually have some kind of generator generating a default one that you have then to change things inside. But you have to say Karma is going to run on this port, and actually the application is running on another one. So, well, you have to do all this stuff. Take care of the different path. It's not that obvious. And you see here there's a line with browsers, and it's actually a JavaScript array containing only the word Chrome, and you can change this and add, well, the browser of your choice, or add many of them, like Chrome, Opera, etc. What I like in Karma, especially if you're working with Angular, is that you can write things like that. Once again, it's in CoffeeScript, but you know the drill. It should show the title. It says browser.navigate to some URL, and then you expect element title.text to be something. And something you can see right away here is that you don't have the stir effect, like you've seen with Zombie, for instance, since it doesn't seem to have any kind of callback here, right? The code seems to be running sequentially. So Angular Scenario gives you all this, gives you a browser object, and then you can do all kind of stuff with this, right? You can navigate to a certain page, assert parts of the DOM, run things here and there, and give you the whole end-to-end API. But it's only available for Angular. So if you're doing something with Backbone or anything else, well, you're stuck, right? You have to use something else. At least Angular Scenario can't help you for that. So it works only for Angular. There's no kind of callback handling, right? And the tricky thing is that every element is a feature, like the kind of the feature in Java. Meaning that whatever is going to be set up there is not going to be called right away. So the main difficulty, if you're doing old-style debugging, like console.log something, whenever in your code to see if it's running there or not, it's going to fail miserably, right? Because everything you have here is just function. So it's very practical because you don't have to wrap your mind around the callback stuff. So when you're coming from the Java world, handling callback is something like you're not used to. So it's very, very good for that. But the bad point is that everything is the future, so you can't do, there is some kind of limitation anyway, right? Because you can't just check or assert things right away. You have to wait for the whole stuff to be running. I think that's all. I think I'm going to show you some kind of demo now. So actually, I've been working on an Angular website for 1 year, and we added, we are working with a pre-version of 1.02, which I think has been live in production has been released last week or something like that. And the main stuff is that I think that now I can speak about Protractor a little bit now. The thing is, Karma was the testing suite for Angular for some time, but as I've told you, it was developed apart outside of the Angular team. And Angular Scenario was like the stuff you need to use when you want to do acceptance testing, right? So there's two separate things. And I think I don't know how exactly, but actually the Angular team said that they're going to use Protractor, which is going to be a new tool, which is going to be based on Selenium. Karma is not using Selenium, it's its own subset, it doesn't conform to any kind of API. And Protractor is going to be the testing suits for Angular in the coming version. But if you take a look at how if you are like me, maintaining a website running for 1 year, and you've written a handful lot of tests with Karma, migrating from Karma to Protractor is not like an easy stuff. So you have to spend some time doing it. And since our whole test suite is running, we didn't look too much into it. That's why we are not going to talk much about that, but keep in mind, I don't know what the future of Karma is. Once again, I think the developer is here, so maybe you can ask him directly. I surely will. But for the meantime, once again, we wanted to show you things we actually did, and not things from the future. So the application we were working on is I think actually commercial software. Can I have the hand here? Yes. And it's a software. It's a software. That's not all at all. What's that? No. Poof, poof. Yes. Don't need that. Okay, it's here. The website is running actually, and we have something like, maybe I can show you this in a TJ. No. Yes, please come in. Okay, we have we have a directory with all the end-to-end tests. I think it's two. Well, maybe if I do this, we have it's a Java project, right? So actually, you're used to this kind of stuff, right? Tag. We have all the Java sources here, all the tests here, all the Java tests out there, and then as the application is mainly an Angular one, we have some kind of components, all the end-to-end testing, which is acceptance testing, all the unit testing, and both are run with Karma. So, for instance, if you take a look at the end-to-end testing, we had quite a bunch of them, and each of them are written in CoffeeScript, and you can add one. There's some kind of stub at the start. Then you can see things like should go to the release detail when I click on a view release. And well, the product actually show you things you can do when you do continuous delivery. So actually, it shows you different kinds of jobs you have to do in a release, and show link to them between them. So you have one task to do, like start up server, do something with database, then deploy, check emails, and this kind of stuff. And it's like a giant to-do list for this kind of, specialized for this kind of job. So actually here, you can check that the browser, the path is the right one. Okay, you can see here all the stuff that Angular Center is giving you. Here, repeater is to get the number of class on this specific element. So you check that you have actually 2 phases, and that one of the phases contains the number of tasks is 3, because there is some kind of phase stuff that contains tasks in it. And then if the phase error is Excel release, which is the name of the product, you can see, why I can't, oh yes, because it's Doom. Then the count should be 1, okay? And you can do this, a lot of stuff like this. And it's running. And actually, there is 300 acceptance tests, but I think it's too much. And it's running in less than 6 minutes. So it's still 6 minutes every time you want to run the test. It's quite fast, but it's still a bit long. And actually, those tests are doing silly stuff with the database each time, so they can't be parallelized. So that's a major point. I think the team is working on this right now. So what it does when it runs, right? Speaking about stuff, there's some kind of script. So here it should start Chrome, and then Chrome is starting, and test actually is running. But they're doing it in the background. So here it is. Here you have different kind of tests, and it's actually picking the application and doing stuff, like all the tests. Here are the calendar. We are going to not spend 6 minutes looking at this, right? Like some kind of epilepsy if you look at this. But, whenever you want, you can put in the code somewhere pause, and it will just run the test. And when you hit pause, it will stop, and you can then inspect in the iframe what's going on. And from all the tools we've shown you today, I think that's the one which gives you the best hand when something breaks down. When you don't know what's happening, actually you can inspect exactly like you're inspecting when you're developing stuff inside the browser. One other things we've seen, which was funny, is that actually the test suite was running on Phantom.js because we think that it was the fastest one. But actually, if you run the tests on those nifty machine here with Phantom.js and Chrome, actually Chrome is way faster, something like 20% on those kind of tests, even though the API is doing lots of stuff here. So actually the CI were running on Phantom.js, and all the developers were running the test in Chrome, well, in different kind of browser. If someone tells you that something is broken on one of his browsers, you have just to change the configuration, and all the tests are going to run in the other browser. So, well, I think that's it for Karma. We may be going to stop it anyway. No, that's not it. Oh yes, and you see here, well, here it was running 163 tests, and I just disconnected in the middle of it. But if there is something which is broken, it's going to show you also the error in the console here. So if you want to capture that, especially on the CI server, to get some feedback to the developers, you can capture that. Way better than having the interface running very fast. The interface running very fast. So, if I do some wrap up on this, what I like, it's a multi-browser system. So actually you can have it running in a real browser that the user actually going to use when browsing your system. That's a big step towards compatibility. If you look at Zombie, which is completely emulated, and Phantom, which is using WebKit, but with some tricks, you know here that it's running in the browser your users can actually use. So I think it's a major point. I really like Angular scenario. I mean, it takes a little bit of time to wrap your mind around it, but once you've started this, I think it's very, very easy. It's quite fast. Still 6 minutes, you're going to tell me, no, it's not fast, but still. It runs quite fast. Not as fast maybe as the others, but quite fast. There is something I didn't show you here, but you can just launch Karma in the background, and then anytime you change some files, it detects it, and it runs the test. So actually it's doing some kind of continuously test suite, which is quite good. Actually, it runs the whole test, so if it's going to take 6 minutes and you test is at the end, maybe it's not the way you should use it, but anyway. I really don't like the fact that end-to-end testing is only available for Angular, but at least it's very good for that. Documentation is the major bad point. I think we've learned everything we had by looking at the source code and looking at Angular tests. I think it's the first time I've seen in a commercial framework as many tests, and the fact that the tests are very put in front for the project. I think Angular has a very good point that lots of people forget, that it's built to be testable. So every time you write an application with Angular, you have no excuse writing tests because it's very, very easy to test. And you have lots of examples. So the documentation actually is the test written by the Angular team. There is some kind of page, but it's very, very thin. One thing I don't like is that browser has to be installed separately. So whenever you set up a new box or new developer box, he has to install all the browser manually. I would like that whenever the thing runs, it installs automatically the browser. For instance, you can do that with Phantom.js. But, well, it's not the case for all. I just don't understand the configuration file. I mean, it's too big. And also, there is Protractor coming in, which I'll give you a small parenthesis about that a few minutes ago. And I think it's going to, I don't know, what's going to be the future of this tool. Anyway, one thing you can see also between Karma and Protractor is that Karma is directly calling the application. When you're using Protractor, it's doing some kind of wire protocol between the different parts, and I don't know how much it affects the performance of it, but I'm sure it's going to, we have to look for this kind of stuff. Well, that's it for Karma. Mocha. Mocha is a favorite of mine. It's actually a test runner, but it's only going to run tests for unit testing, right? It's a test framework. It's run on Node, and you can load it up in a browser. It's able to run synchronous and asynchronous tests, both of them. And there is out-of-box integration for a major Java CI system. So you're in common ground here. And it's compatible with chai.js, which is an assertion library. We'll talk about this a few slides later. And it's quite a matter. I think now it's 1.14, but anyway. It's very simple stuff. Actually, you can, that's an example. Actually, it's the tool I've used to do the zombie demo before. So actually, you can start with nothing, right? You just npm install Mocha, and then you're ready to go. It comes with, if you install it globally, it comes with some kind of binary, so you can use it everywhere. So here, it's using the default assertion library, which is available in Node. So it says, I should uppercase the first letter. So you see here, you have describe, then you have to it, which enforce the fact that you want your test to be readable. So it says it should, etc. And there is actually many ways of writing tests. Mocha supports different ways of writing. So if you don't like the describe it, there is 2 or 3 other ways to write your test. So if it's not if you're not in the mood of writing tests like this, you can change it. Oh, I don't have chai now. Okay, let's. Oh, why are we? Yes, let's go for the chai and we do the demo afterwards. There's mixed up in the slide. Sorry. Chai is an assertion library. It's actually the stuff who does just the assert. Okay, you have to use an assertion library inside a test runner. It supports 3 assertion test style, so it's also again the tool where you can choose a bit what you want to do with it. It runs in Node. And the 3 assertion style are here. You're the classic one with assert. You assert something. There's the expect thing, which is a bit more like the thing you can have in first assert, for instance, in Java, where you can say assert that to be equal or to is equal to. And then there's the one which I like, which is a bit tricky, which is the should style, which is at the bottom here. And he actually changed the prototype of every object which comes in, and is going to add some should methods, should function, sorry. So every time you have some kind of object in it, you just take this object and say should something on top of it, because it has changed prototype inside it. It's a bit like magical stuff, but it's quite easy if you bear the fact that it's going to mess up with your objects. So now I can go back to my demo. Sorry, and let's get started. So let's make some directory. DEVOXX demo. So I start from scratch, right? Nothing in. And then we are going to write some coffee code. So I just create. Is that readable? Okay. So I have an empty text file, and I say should, which loads up require. Okay, sorry, it's going to fail here because we need. Well, let's test, but I think it's going to fail. So that's the basic stuff, and if I launch Mocha on it, okay. Yes, let's try again. Here. Yes, okay. Because it needs some kind of modules, and the directory where I was didn't have those modules in the path. So actually, I'm just checking that my thing is working. And maybe we can take the example of the FizzBuzz we had before to show you a little bit how it's working. For instance, just with that already, we can see here that you have foo, which is a string, which suddenly has a should method, right? That's the should here, and chai who has done his stuff, right? You actually has changed this. So you can write anything and have a should on top of it. So let's say that we want to do the FizzBuzz stuff. And the first thing with FizzBuzz, FizzBuzz is a thing where you write different kind of numbers, and when numbers is divisible by 3, you're going to write fizz, and by 5, you write buzz instead. So it should be 1 for FizzBuzz of 1, for instance. And then I should write something like FizzBuzz of 1 should equal 1. And run this. Unable to write file. Oh, cool. Okay. FizzBuzz is not defined. If you see this, yes, you can see this. And actually, you can. Mocha has a many kind of stuff here. You can see that I just asked him to write. I told him that we were using Coffee, so he has to load some kind of Coffee script compilers. Most of the tools actually does this by default, but I don't know why in Mocha you have to ask him specifically. He has some kind of watch stuff, so you can ask him to watch your file. So every time you change something, it's going to run the test. Here you don't see it much, but that's what he's doing. And then you can also change it the way he has many reporters. Reporters are the way that he's going to show you the results. And you can see here all the reporters he has. So for instance, you have JSON stuff, which is going to give you a JSON result of the thing. If you're more into TeamCity stuff, he has a default TeamCity, the CI server TeamCity, which is able to give you things. I think he has QUNit somewhere just on top of it. So if you want to add this in a Maven build, just produce, or if you want to see it in Jenkins, you can just hook up and tell Jenkins that the QUNit files are there, you have the result. And also you have nyancat, which is going to write some silly nyancats every time the tests are run. I think maybe we can show this. Oh, you see it here. Well, and it's going to grow as much tests you have. Well, if you want to have some funky things, you can have them. Actually, I use the spec one, which is going to give you the kind of the test here, FizzBuzz, and then all the tests here. So we're going to reduce this with the watch parameter. It's going to check that. So let's get back. We don't have the FizzBuzz function. Let's define a FizzBuzz function. It's going to be a function with a parameter, and it's going to return 1. Let's say yes, we have one test passing. If I want to write another one, just to make the things a bit harder, it should be 2 for 2. Oh, we don't have this, so we have to change this to value, for instance. You see how quickly you can be running without much tool. I think here I'm using Sublime, which is a rather basic editor, and I just have a console there, so you don't have to load up much things to have to be running. Should be fizz for fizzbuzz of 3. No, there is no comma in CoffeeScript, right? Fizzbuzz of 3 should equal 3. No, that's pathing. That's not the point. Oh yes. Oh, here should be fizzbuzz like returning 3, and at the same time, all of this should be string, right? So everything is failing now. Why? Because I was returning the value itself, so I have to change that. Oof. In CoffeeScript, you can just add this, and it's converting the stuff. And now I have to return fizzbuzz. Look, if the silly implementation could be something like, if value is 3, return fizz. Is it with a? No, it's okay. No. Yes, not fizzbuzz. Okay.
Fizzbuzz.
You have to know the thing. Okay. For instance, to take a look more deeply, it should be undefined for fizzbuzz of undefined, for instance. Meaning that whenever the value does not exist, I don't want it to fail. I just want it to return something. And actually, you can't write undefined that should, right? So if I write something like fizzbuzz of undefined should not exist, you can't write that. Actually, should give you this kind of stuff. Should not exist, I think it's should not exist, the fizzbuzz thing. Should be expect undefined not to exist, then you have to do something like here. So just to show you, here should also can do some, chai can do some DP call stuff. So actually you can check inside a map that lots of stuff are already here. It should contain part of the string. I think I showed you this before. For instance, I can write something like here, should contain oof. Oh yes, you have to write proper English. And well, you see there is lots of different assertion type in chai, and with Mocha you have a very lightweight way of doing this, and I think it's a very good way of writing unit testing. Yeah, you can wrap this up in Karma, actually. You can tell Karma, hey, Karma, this is I want to run all those tests in Mocha, and then it's going to take this and run it inside a different kind of browser. Let's get back to this. I think it's your turn. I think it's your turn. I've done the chase stuff.
Yep. You have the wake up. Or not.
Are you ready for that?
You had the summary slide. Okay, so we'll continue with Buster.js. So Buster.js is, well, pretty much a challenger for Karma. It's a test runner, like Karma, with some specificity on some very new features for a test runner. There are multiple launch modes. You can launch it pretty much from everything. You can launch it as a node module. You can use browser capture like Karma. You can use its own embed static server to start with static HTML and launch test. You're supposed to be able to launch it inside the browser, like QUNit, for example. It's still experimental for now. And you can launch it with an headless browser like Phantom to launch a test inside a fake server. Great. It's from the author of Sinon.JS, so it ships with Sinon.JS, with all the great features of the library. Okay. Yep. There are two syntaxes to write tests, like we shown in chai, but only two, not the third. There is the QUNit format and the BDD format. So it's one with setup, teardown, and test with assertion, and the describes with before, after, and expectations. Very classical. You can do nested test case. So usually it's in the BDD format that you can describe something, then describe inside the first describe to specify. Well, with Buster, you can do the same, but with the Unix format. You can, for example, define a first test with setups, then define another test which will be a suite, where you can define another setup and another test, or another test. Like Karma, there is a very heavy configuration file where you can do pretty much everything. You define extensions. You have to define your JavaScript source, your JavaScript test source. You can expose static resources. You can proxify resources from other servers. For example, you can start your backend Java server and ask Buster to proxify resources. You can do the same, for example, with Grunt Connect plugin when you're launching Karma test inside Grunt. But Buster do it out of the box. There is some new features I don't think I ever saw in another test launcher. There is no assert is not something. Instead, he inserted a refute keyword, which do the same but in the opposite way. For example, there is no is not null. There will be a refute for is null. It's original. I don't know if it's really useful, but well, it's a difference. You can disable test with adding a double slash before the title, which can be very useful because during a refactor, sometimes you have to comment test. But when you comment the whole test, you may forget them. With a double slash comment, the test will still appear in the test list, but will be flagged as commented. So after your refactor, or when you have the need to, you can uncomment the test. It will always appear in the test list. And last thing, you can define prerequisites for test. For example, if you need to test many features in many browsers or mobile device, you can test support before launching test. It can be used, for example, to filter a mobile device or touch screen before adding a touch test, like in the example on the right. So in a few words, it's still very young. It's a beta 07. It was a beta 06 when we did our presentation in DEVOXX France. So it's not moving really fast. But the core developers have a very precise idea of where they want to go. And I think if one day it goes out, it's released, it will be a worthy challenger for Karma or any other mature test launcher. I think now I won't have a demo for Buster. Okay. We've done our presentation of test runners. We'll do just short slide about JS Cover and Plateau, which are not test runners but are used in test quality tools. JS Cover is a test coverage, code coverage tool for JavaScript. Code coverage is very common in Java. Any CI usually do it. Sonar, for example. Well, It's not really a CI, but you can do it with Sonar. It's very harder to do it in JavaScript. Some test runners does it out of the box. For example, JS Test Driver does it. I think Karma more or less have a plugin for coverage. But when you're using other frameworks, it simply doesn't exist. You cannot have code coverage for JavaScript because it's not native in the language. In practice, what you have to do code coverage is to programmatically add assertion before and after each line of code, saying, okay, I was there, okay, I passed this line. So this is what JS Cover does. You have two ways of doing it. You can do it at build time. For example, before you decide to launch your test suite, you can ask JS Cover to instrument your code. It will generate new sources which are instrumented. And if you ask your test runner to use these files instead of your original files, you can generate coverage. You can also use it in runtime using proxy. You can start JS Cover as a proxy, and you can access your website, or you can ask your headless browser to access your site using the JS Cover proxy, which instruments your files on the fly to allow easier code coverage. Both instrumentation modes are kind of hard to integrate in the build time, because you at least have to say, I want to generate the files and I need my test runner to use these files instead of the original sources, which can be kind of hard. And the runtime appears to be easier, but in real situation, you have to ask every browser accessing the test to use the proxy, which means starting the proxy, starting the browser, configuring the browser with the proxy. Sometimes it's harder, even harder than the build time mode. So it's kind of hard to use, but what I didn't say is that it generates cobertura format files, so you can, after this, integrate it in Jenkins, in Sonar, or in any CI. The result page, which is kind of ugly, but at least that's not what we ask him to. And the detail view. You can choose any file. For example, this is the results for jQuery. Yes. And in the detail view, you can see for each line the number of times the test passed on the line. The detail on the result view are not that useful in practice. It is easier and it's more visible to integrate it in Sonar and to check using the Sonar code coverage, which is a little less ugly than that. So it does what it's supposed to do. I mean, when you need code coverage and you're not on JS Test Driver or Karma, I think it's pretty much the only solution, actually. It's an active developer. He's actively developing and backporting from C++ to Java. And the results can be integrated to CA. So it's doing the tricks. But it's really a pain in the ass to integrate. It's integrating JavaScript test in a Java project build process is hard. Integrating code coverage for JavaScript in the same build is even harder. And Plateau.js, which is a source complexity visualizer. which is kinda a fancy word for saying I generate many indicators and fancy dashboards.
I can show you this. My manager would be happy, I believe.
Yep, it's pretty much used for code report and fancy meeting with with IT heads. But there is a few indicators that's still useful. I will show you the generation myself because it's kinda easy to use. I downloaded the jQuery files, which are there, and I will just generate it. So it's simply plateau, the path of the folder, that's all. It parses recursively, and it generates reports. I should just have to open it. Here we go. Here we are. So there is a summary with the total lines, many indicators, for example, the average maintainability, which is calculated, I don't know why, but it is. The maintainability level for every file. Where am I? Maintainability, the number of lines of code, estimated errors in implementation, which is another algorithm-based indicator, lint errors, and details per file. For example, the maintainability, lines of code, difficulty, estimated errors. Very interesting. Here is your code, and you can define the number of errors in it. It's magical. I don't even know why we developers are there. And there is the GSLint detail, which can be useful sometimes if you don't use ID. And that's pretty much it. It doesn't do anything else. But at least it's fancy and beautiful. I think we're done.
You have 2 more slides on this.
Yeah, but it was the demo I showed. Oh, sorry. I switch it off.
Yep. So, maybe you can talk better.
Yep, at least. So it's very easy to install. It's an APM module, so it's npm install plateau. It's very easy to use also, and it generates beautiful dashboards. In our project, it was at least it was useful in high-level meetings to show code quality. It may be useful.
You get a raise out of it, right?
Yep, that's the goal. But the reports it generates HTML reports, which are also available in JSON, but there is no exportable format, so you cannot export it to a CI, to a Java CI at least. So it's a fancy website, but that's pretty much everything.
Okay. So the goal of the talk was to give you an overview of those tools. So we give you an overview of acceptance testing tools, give you an overview of the unit testing tools. We ended up with things from for making reports. And the main difficulty on this is when you change languages, like when you go from Java to JavaScript a bit, or you do polyglot programming, like doing a part of your work in Java and a part of the work in JavaScript. When you discover a new language, it's not the language itself which is hard. The main thing is all the ecosystem, the environment, which is about those tools, which is hard. I mean, if you want to learn JavaScript, you can learn that pretty fast, especially if you're fluent already in Java. So the goal of the talk was to give you a bit of insights of what we've gone through, and so that you discover a little bit the ecosystem around the JavaScript things. And all the stuff we've shown there have been used in with the Java backend, right? We didn't do the full JavaScript stack. So let's wrap up quickly. First, we didn't cover everything. Once again, we talk about things we actually used. So to give you a frank and transparent feedback, we are not vendor, right? So we just give you, we share our experience. There is many more tools. The first one is GS test drivers that we didn't use. I think you didn't like too much the architecture of this one.
No, it was.
It's
very heavy. In fact,
it's heavy-duty stuff where you have to set up servers that run things here and there. So I think testing is already, especially acceptance testing, is already quite difficult. So we didn't. We weren't attracted by that. We didn't speak about Selenium. But I think that it can be, it is actually a good thing, especially with the grid system, where you can actually spread your tests around a Selenium grid to give you different kind of results. And I think that in the Java world, there is the Fluent Selenium library, which actually is going to be demonstrated by Mathilde in not the talk just before, but the talk after, which is going to show you a live demo of this. And Fluent Selenium, if you stay in the Java world, is maybe one of the good tools you can use. Actually, I like, my philosophy is that if you're going to write JavaScript, why not test it in JavaScript, because you're already fluent with this language, and at the same time writing your test in JavaScript is going to make you more experienced in it. But if you still can make your mind around JavaScript and you still want to use your Java stack for this, well, you can still take a look at Fluent Selenium. It's quite a very good tool. If you don't have much JavaScript or very light one, like just a little bit of jQuery without Ajax call and all this stuff, maybe you can still use HTML unit. For simple stuff, it does the job. We didn't use too much Jasmine, but actually, if you take a look at Jasmine, it's quite similar with Mocha. Right? They are about the same stuff. Jasmine is quite older. It was there before. It's able to run out of the browser test code. And then you have Istanbul, which is kind of
like JSCover.
Yes, like JSCover, which we didn't also use, but they are quite big actor, big tools in the field of this talk. That's why we wanted to have some words about them. So wrap up. For unit testing, we still kind of use this three kind of stuff. We prefer to test out of the browser for this most of the time, because if you're doing unit testing, why should we spend some time in a browser? A few years back, it was almost the only way to run JavaScript efficiently. Now you have Node, V8, which allows you to run this inside a console. So I think that we've made a huge step forward. Our stack of favorite is the Mocha plus chai.js, but you still can use the different kind of stuff you have, especially if you're into mocking and stubbing. I think Sinon is really mandatory. So if you have a heavy-duty JavaScript code that you want to mock away, you can use this. And then if you still want to click on things to see your test results, you can use Jasmine or QUNit, especially QUNit. For user interface testing, I kind of like Zombie myself quite a bit. We spend half a lot of time with it, and I think it's still quite reliable. But I know that, for instance, I think it doesn't run on Windows, period. So it's a major point, because most of the team are still using Windows. And it's quite sometimes a bit tricky, and I think it brings fear, right? The fact that it's not a real browser, it brings fear. You're not confident with it. I kind of like it. I spend some time on it, and so I think it's still a very good tool. And I hope that version 2 will bring more reliability to it. CasperJS, I think it's a way to test with Phantom on top of it. I still myself don't like too much the API, but there is lots of progress which is made towards making it more readable. So it's still good. And of course, Karma, which I think if you are making a website with Angular, don't spend your time with Zombie or Casper. Just run inside and take a look at Karma in Angular scenario. And if Protractor has gained some momentum until the time you start up your project, maybe you should take a look at that and ask a little bit more what this Protractor stuff is doing and who's using it. In the radar, that means that things, well, we talked about this already. I was saying about Zombie.js downfall because we didn't know what's going to be yet, because the development was not that much effective. On Buster, maybe you can say something?
Yes, on Buster, well, development is very active, but it's kind of hard to follow Karma with a big Angular community behind. I don't really know where it's going. There is no really milestone for now. I think the V1 release will be at least 214.
And we talk about protractors. I'm not going to talk about this again. And happy coding and testing, right? Don't forget to test. I think that's all, right?
Yep.
So
that's it.
We have 2 minutes left. So if there is any question, we can take them. Or so if you have any question, it's about now. Okay, everybody is sleeping and didn't understand any JavaScript that we wrote today. That's okay for me. Thank you for listening. We are here for the next day, so if you want to catch up with us, we'll be happy to talk about this. Then happy conference.